Texturology. Image to PBR material with AI.
Hello and welcome, creative minds. In the world of 3D, our quest for realism often leads us to a common and frustrating obstacle, the texture seam. That visible, jarring line where a texture repeats, breaking the illusion we work so hard to create. Today, we're going to solve that for certain textures. I'll show you how to transform a non-tileable texture into a perfectly seamless material right inside Blender for free. Our journey begins with a fantastic free tool. On the official Blender extensions platform, you'll find an add-on called Procedural Tiles. This powerful library with over 100 nodes is the foundation of our solution today, a testament to the open source spirit that fuels our community. Now, why is this so important? Many of you might be using AI tools to generate PBR materials, like my own recent launched addon, Texturology, which you can see here. It masterfully converts a single photograph into a full set of 6 PBR maps: base color map, normal map, roughness map, height map, and Caucasian map, and curvature map. However, a photograph of the real world is rarely seamless by nature. So when you generate your maps, you inherit that problem. You get incredible detail, but with visible borders, every time the scale at which we use the texture increases. And that's precisely the gap we're going to bridge today. This tutorial is a companion to Texturology. I've created a special node group, which you'll receive with the addon, that leverages the power of procedural tiles to make any of your generated textures seamlessly tileable. Think of it as building a bridge between two powerful islands of creativity: the raw, detailed output of AI and the flawless, repeating surfaces your scenes demand. If you haven't purchased the add-on yet, you can copy the node set from the Procedural Tiles page on the Blender extensions website. Alright, let's dive into Blender. The first step, if you haven't already, is to install the Procedural Tiles add-on. Simply go to Edit, Preferences, Steps Extensions. From here, you can search for it and install it directly from the online repository. Once enabled, it grants us access to over 100 new shader nodes. Here in the shader editor, you can see the node group I've prepared for you, named Make Seamless. This is the heart of our operation. It encapsulates a complex network of nodes from the Procedural Tiles extensions page into a clean, easy-to-use interface. We'll be connecting our texture coordinates to this group, and it will magically handle the blending. Let's start with a perfect candidate for this technique, a grass texture. It's organic, chaotic, and what we call a stochastic texture, one without a rigid, repeating pattern. A stochastic texture is a surface pattern whose look comes from random, small-scale variation. Think sand, granite, moss, or skin pores, not from repeated shapes or motifs. Unlike tiled or pattern textures, bricks, tiles, logos that show obvious repeats, stochastic textures are defined by their statistics: grain size, contrast, distribution, so they read as natural and non-repetitive when spread over a surface. This makes them essential for realistic materials because they avoid obvious tiling and keep the surface feeling organic. I'll quickly set up a basic material, plugging in a base color, roughness, and normal maps. Now, watch what happens when we scale the texture using a standard mapping node. As I increase the tiling to 5, and there it is, the grid. The repetition becomes obvious and the seams are painfully clear. The illusion is broken. Here comes the magic. We take the output from our mapping node and plug it into the vector input of our Make Seamless group. Then, we take the vector output from the group and connect it to all of our texture maps. And just like that, the seams vanish. It's like magic, but it's really just smart math and procedural wizardry, creating a beautifully blended, infinite surface. Let's explore the controls this node group gives us. The tile size slider controls the size of each procedural cell. A smaller value creates more, smaller tiles. Real scale then scales the entire effect up or down. The most important slider is Tile Mix, which controls the softness of the blend between the tiles. A higher value creates a smoother, more gradual transition. Below, you have controls for adding procedural noise to further break up repetition, with sliders for scale, detail, and roughness. This gives you complete artistic control over the final look. But a true master knows the limits of their tools. This technique is incredibly powerful, but it's not a universal solution. To understand why, let's switch to a different kind of texture, this piece of wood. Unlike the grass, this texture has a highly structured, directional pattern, the wood grain. In other words, it is not a stochastic texture. You can see the seams are even more pronounced here. Now, let's apply our Make Seamless node group. Technically, the hard edges are gone, but look closer. The beautiful directional flow of the wood grain has been lost, replaced by a blended, almost smudged pattern. We've lost the very character that made the texture appealing. And this reveals the soul of the technique. This method excels with stochastic, non-directional textures. Think sand, concrete, asphalt, stone, or grass. It works by blending the edges of procedural tiles, which is perfect for patterns that are inherently random. However, for textures with strong structural patterns like wood grain, bricks, or geometric fabrics, this blending process will disrupt the very structure you want to preserve. So, the key takeaway is to choose your battles. Use this powerful seamless technique to perfect your organic and random surfaces, and for your structured materials, you'll still want to rely on traditional methods or textures that are already designed to be seamless from the start. I hope this deep dive has been incredibly helpful for your workflow. As a reminder, you'll find this very Make Seamless node group packaged and ready to use with my add-on Texturology. You can find the link in the description below. But if you just want to use the technique, I repeat, go to the Blender extensions page and copy the workflow from the last video in the gallery. Thank you so much for watching, keep creating, and I'll see you in the next tutorial.
Texturology. Image to PBR material with AI.